We saw how to use the this keyword in the last video, and one of the places where it'll come in handy is when you overload the assignment operators for a class. So there's a couple of things you want to keep in mind about the assignment operator. Assignment operator returns a reference so that you can have this cascading chain of assignments. To make this possible, you have to have the assignment operator return a reference, just like we did with the insertion operator. You also want to allow there to be parentheses between a equals b, and we'll take a look at that in the context of ints. So let's just do that right now, just to make sure all of this makes sense. Let's say we have this simple program with these three ints, x, y, and z. We can initialize them with what looks like a constructor, but this is possible in C++. You can initialize x to 1, y to 2, and z to 3, and then when you print it out, that's what you should see is x is 1, y is 2, and z is 3. And you should be able to do an assignment of this form. Like, if you haven't seen this before, this is also possible in Java. This works. What this does is you have to remember that assignment is right associative. That is, it says you do this first and then you do this. So you assign the value that's in x to y, and then this whole thing has the value in y. So which is the new value, which is 1. 1 goes into y. This whole thing has the value 1. So it's like saying z equals y. So which means that when you print everything out the second time around, it should print out all three of them to be 1. So let's run this real quick. Okay, so initially x is 1, y is 2, z is 3, just as we initialize them. And then after the assignment, actually after the cascading assignment operator, we know that this 1 goes into y, and so then y, which has the value 2, will be assigned, which had the value 2 and became 1, now will be assigned to z. That's why all three of them show up as being 1. Now we can do the same thing with classes. So I'm going to use this class ABC, which I have already defined. Just going to bring it up. So we had ints over here, but we can do all of this if you overload the right operators and set up the class the way they're supposed to be set up. So my class ABC has a constructor that takes a single int, and that's assigned to the first location of this array. So I have a data member that's an array of 5 elements, and it's a I wouldn't say static data member, but it's a static array in that you allocate a array of fixed size. And we're using this in we're not using dynamic objects here. We're using quote-unquote, I guess, static objects. They're not static in the sense of the static keyword, but they're static memory objects. Okay, so then what we do is in the constructor we just assign whatever value you get to the first location, and actually it turns out that's the only location we really use. For get method we just return the first location of the array, and so we've overloaded the insertion operator as we've done in the past. It takes 2 arguments. So this is a standalone function, not a member function. And it takes 2 arguments. The left-hand side is the OStream operator, so that we can use this. Right, so when you say insertion x, you're saying the left-hand side has to be an OStream object, that is cout. So in this case, this whole thing is cout. So this is very analogous to this, except that in this case, the normal interpretation is that x is assigned to y, and then this whole thing returns y, which is assigned to z. Okay, so let's try this out. Let's compile this. We just switched everything from ints to classes. and do the same kind of thing we did with ints, and in this case we are printing out pointers, and so that's not tremendously useful, but it does tell you that x, y, and z now are objects, and because this insertion operator is overloaded to insert the location of this array, that's the location of the first element of the array, we see that this is actually interesting information, which is that x, y, and z, all three of them have different array locations. So the arrays are in different places, they are distinct. Okay, that's important. Now we'll change this to use get, and we're going to switch from getting a pointer, that is the location of the first element of the array, to actually getting the contents of the first location of the array. Alright, let's do that. Builds, runs, and just like with ints, we get the same thing. Initially, x is 1, y is 2, z is 3. That is, when you say that, what I really mean is that the x object has an array with the first location set to 1, and similarly y object has an array with the first location set to 2, z has an array with the first location set to 3. So that's what they initially were, and then you do z equal y equals x. You have a cascading or chain of assignments. So from this we know that this 1 that's in x is assigned to y, which is assigned to z. And also we know that just because we printed out the address of the first location of the array, or that is, since we can print out x, we saw that they stay different. So when you have a array like this that is not dynamically allocated, what C++ does automatically is when you have an assignment operator, it calls the copy constructor, and it actually keeps the same array that you had in y. So you don't actually copy the if you look at the x object, that had its own array. It copies the contents of that array into the array in the y object. And then for z, it takes the result of this, and the result of this is the y object, and it copies the array that's in y. All of those locations are copied into the array that's in the z object. Okay, now let me just switch back to ints. Int, and everything should work. Just check and make sure. Okay, that's all good. Now, the kind of thing that you can do in Java, you should be, in C++, is you should be able to do this. You might say, well, what does this mean? This means that y, now you're breaking the normal or the default behavior. You're saying without the parentheses, you're assigning x to y first, and then this whole thing has the value y, and then y is assigned to z. So that means 1 gets assigned to y, so y changes from 2 to 1, and then that 1 in y is assigned to z, and now z changes from 3 to 1. However, you can also do this. Let's just check and make sure it compiles, and let's run it. And now notice there's a slight difference. What happened is y, which had the value 2, is assigned to z. So now z changes from 3 to 2. And then it sort of doesn't make sense, but what you're doing is you're assigning the value in x to z. So now, even though we just wrote the value in y into z and changed from 3 to 2 for a short time, we very quickly, the very next step is to take the value in x and assign it to the value in z. So this whole thing, this whole expression basically returns, you can think of it as a reference to z. Okay, so this thing is z, this is saying z equals x, and that's why we see here x is 1, hasn't changed, y is still 2, has not changed. Z is assigned the value in x. So C++ allows you to do this. Java does too. It sort of doesn't make sense, but in general, you might want, this is the kind of thing you might want to allow. And sometimes it actually does make sense to do this kind of thing. This particular case, maybe not so much, but you still want to set up your operations to allow this kind of statement. So A, B, C, you want to allow this to. Okay, for objects 2, you want to allow both the use without parentheses, which makes total sense, which saying assign everything in x to y. This whole thing is then becomes this is just like saying z equals y after you've assigned x to y. Okay, so you go from right to left. I guess that's the easy way to think about it. Is for assignment, go right to left. But you also want to be able to do this. And C++ does have default behaviors associated, and it works the way you would expect it to work. So just like with ints, you've assigned x to the result of this. The result of this whole thing is z, after you've assigned y to z. That assigning of y to z, as you can see, is doesn't do anything. All this does different is that y is not assigned the value x. That's all. And you might say it doesn't even make sense to do this, but actually there are situations where these kinds of things come in handy. This is not one of them. Okay, now let's take a look at the notes, see where we are. Okay, so when we overload the assignment operator, turns out that's one place where we use the this pointer. Okay, the reason is that the assignment operator must return the same type as its left-hand side, just like we did with the insertion operators. So remember, with the insertion operator, we treat this as insertion dot left-hand side, which is cout, right-hand side, which is anything, in a string in this case, or an object in this case. So we have to allow this to work, we need this overloaded insertion operator with the left-hand side, right-hand side, and then remember we always return the left-hand side. So the left-hand side is the same type as the first operand. Okay, you want to do the same thing with assignment. Pull that up. Okay, so if you want to do stuff like this, if you want to cascade, you want to think of this as one thing, and this should return the same kind of object that B is. Okay, so the operator must return the same type as its left-hand side. And to do that, we have to use the this pointer. So let me pick up from this point in the next video.